Good morning, good afternoon, good evening, whatever the case may be. We are indeed back and better than ever. Still Pi Day on this taping day of the video. Love the Pi. There's the tribute. Let's get to it, shall we? Okay, last video, binomial distribution part 3. This is the easiest part. We need to be able to find the mean and standard deviation of a binomial distribution. Okay? And the formulas are very, very, very easy. The mean of the random variable x is represented by mu, as it always has, which is equal to number of trials times the probability. Standard deviation is square root of mp times 1 minus p, so the mean times the probability of failure. Oh, square root of it, did I say that? I can't remember. And of course the variance would just be whatever is in the square root mp 1 minus p, all beautifully displayed here on your formula sheet, except for standard deviation. You just have to know to find standard deviation, you take the square root of variance right here. And from the last video, I'm sorry I didn't have it up for the example. The expected value mean, or the mean, is NP. All right, let's get to it, shall we? A fair die, it's not loaded, is rolled 12 times, and the random variable x is the number of sixes that could result. Find the mean and standard deviation of the x distribution. So let me grab that and put it here. I wish I had done that before. Okay, I'm going to put it here, and let me put it for the next example. Sorry for the administrative, blah, blah, blah. All right, a fair die is rolled 12 times. Random variable x is the number of sixes that could result. Find the mean and standard deviation. Ready? So mean, is equal to number of trials which is 12, times the probability of success. What's the probability of rolling a 6? 1 out of 6. Could this be any easier? Okay, so the mean is equal to 2. I mean, how easy is that? Okay, and let's see, what else do we need to find? The standard deviation. Well, the standard deviation, sigma, is equal to, I just use my variance formula and take the square root of it. So that's the square root of np times 1 minus p. Well, np we just did here, didn't we? np is equal to 2. Or if we want to follow this formula exactly, that would be 12 times 1/6 times 1 minus 1/6. Yes? Say yes. I didn't hear you. Say yes. So you crank that in your calculator and you get it approximately equal to 1.29 to 3 sig figs. 1.29. Could that be any easier? I don't think so. Okay, so if we, what does all this mean? If we roll a fair die 12 times, we expect a 6 to be rolled twice with a standard deviation of 1.29. That's what that means. Last example, 5% of a batch of batteries are defective. They don't work. Why don't they work? I don't know. I don't know. They don't work. Why not? I don't know. I'm sorry. A random sample of 80 batteries is taken with replacement. So we can use binomial, boys and girls. Find the mean and standard deviation of the number of defective batteries in the sample. Same type of problem, little bit of a twist. Okay, this is a binomial sampling situation. Let's write down all our stuff because it's maybe we should have done that on the previous example. Number of samples, number of trials is 80. The probability of success. Now this is weird, and it's going to be 5%. okay, which is equal to 1 out of 20. And you might say, but wait a second, defective is a failure. But in our case, we're looking for those that are defective, okay? So defective is success in this experiment. Hopefully that makes sense, because that's what we're looking for. We're after the number of defective batteries, or the mean and standard deviation of that. So that is our success, even though the batteries are failing. So if you don't like it, build a bridge and get over it. So here we go with the hard calculations. The mean is equal to NP, which is equal to 80 times 1 over 20, which is equal to 4. And the standard deviation is equal to the square root of the variance, NP, times 1 minus P. All right. NP, we just did it. I'm not going to rewrite that again. So that's the square root of 4, 80 times 1 over 20, times 1 minus P. Well, let's see. 20 out of 20 minus 1 out of 20 is 19 out of 20. So that is approximately equal to 1.95. So in a random sample of 80 batteries, we expect a defective battery 4 times with a standard deviation of 1.95. Ladies and gentlemen, that is all I have for the binomial property distribution, or the binomial distribution. It is still Pi Day. I have not gone on infinitely, so let's take it out with the final part of this wonderful song. I've done all the damage I can do, and I am out!